Okay. So we are going to look at surface tension today. We are going to look at surface tension. So in our books, we write surface tension. Now, I'm going to first show you a video of what we are going to look at. But before that, have you ever seen insects walking on water?
Yes.
Like these insects, No, they are normally in village whales. Village whales, these ones here. And now Pav doesn't need village whale. Just knows only the tap and what. Even that here, the same thing. So village whales, when you go to the village, there are some wells which are just dug, they just dig, and then water comes from the springs. So even you use those, some of you use those wells, but you come to Kampala and you pretend around. Sean, isn't it? So we have these. So we have these insects. They move on water surface. I don't know what makes them to float on water, but we are going to find out really what makes them. And what is this, members? What is this? This one.
I need.
It's a what? Hey, you have just seen it from here. Okay. It's a sewing what? A sewing needle. So when you place it, have you ever tried to place a sewing needle on water? It will float. No magic, but that needle will float on what? Will float on water. Will float on water. So there are some things that show surface tension, but I want us to first look at this. Hope you can see what is on the screen. So that is a coin. It's form of a coin. I want you to look at it very well. That is in the form of a metal, and once it is put on, once he puts it on water, that thing sinks to the bottom. Because he has not put it carefully. Now he has put it on the surface of the water carefully. And you see what is happening? It is floating. He has even added a second one. So he is showing you what is happening inside the liquids. So he adds more and more, but they are floating. This is water, not oil, but that is water. And these are metallic. So, okay. So I want you to ask yourself really, what do you think surface tension is? What do you think surface tension is? You have seen he has put these kind of metallic, are they coins or what, on water, and now they are floating carefully. He has placed them on water using a fork, and they are floating. What makes them to float is surface tension. Now, what do you understand by the term surface tension? What do you think surface tension is? Is it the magic that makes things to float on water? Who knows? Who can try to define what surface tension is? Yes, Ruth.
Surface tension is the force that allows objects to float on water.
Is the force that allows objects to float on water. Okay. Hmm? Thank you for trying. If I was to give you some marks, I would give you like a 3 out of 5. So who knows what surface tension is? Okay. It is a force that, let us first listen. Let us first take Ruth's answer. It is the force that allows objects to float on water. It's true. That force allows objects to float on what? On water. But surface tension, can it make even human beings to float on water? Is it possible? Sean, can you float on water because of surface tension?
No.
No. It is not possible. Why is it not possible? Because if it is a force that allows objects to float on water, then it means that this force causes something on water. There is something on water that is there and makes objects to float on it. So on the surface of the water here, it's as if there is a certain membrane or there is a small thin skin on the surface of water. So surface tension makes the surface of the water to behave as if it is having a thin elastic what? Elastic membrane or elastic skin, such that any object that is carefully placed on the surface of the water will tend to float on that surface of water. So it is just a thin elastic skin. That's why human beings may not float on water, because the membrane that is there is just thin and it is elastic. It is thin and elastic. So it is a force that makes the surface of a free surface of a liquid to behave like a thin, stretched, elastic skin. That is surface tension. Are we together? Are we together?
Yes.
Yes.
Here they are defining surface tension as the force on a liquid surface that makes the liquid surface behave as if it is covered with a thin elastic membrane or skin. A thin elastic membrane or skin. So there is a force that makes the surface of a liquid to behave like a thin elastic skin. Are we together? So can we write the correct definition of surface tension from that? There is a force on a liquid surface that makes the liquid surface to behave like a thin elastic skin, or you can say membrane. That's surface tension. So we have examples showing surface tension. The examples showing surface tension, and one of them we have already seen from these diagrams which are here. Okay, we have seen. So we have insects that are able to walk on water, but before that, they are saying that when water drops slowly, it breaks into continuous streams and forms droplets. This shape of the drops is caused by surface tension. Okay. So when water drops on any surface, it creates given drops on that surface. What causes those droplets is the presence of surface what? of surface tension. But let us first write the ones which are mainly. So the first one is several insects are able to walk on water. So several insects, that's one example. Several insects can walk on water. Such insects, for example, e.g., we have water striders. Okay, water striders. The number 2, you can write this third one here. A pin or a sewing needle, when gently put on a water surface or when put on surface of water in a container, it floats due to surface tension. So you can say that a sewing needle, when gently put on a water surface, floats. So if you have a sewing needle and you gently place it on a water surface, this needle is going to float. The reason is it is due to surface tension. So sewing needle, when gently put on a water surface, floats due to surface what? Due to surface tension. Then the other one we can say water when we can say water when slowly drops, forms continuous streams and drops due to those are some of them. And there is also another example. If you don't put a needle, you can also put a what? What can you put on a water surface if you don't put a needle? Guess. Yes, Sean?
A coin.
A coin. You can place a coin. You can place, okay, it was not a coin, but you can place something that is not very heavy because the surface of water just behaves like a thin elastic membrane. So you can place a razor blade. It's called razor blade. It's razor blade. Razor blades, when carefully placed, when gently placed on what surface? The water surface floats. Okay, so those are some 4 examples that I've given you. Okay, now here they are saying that there is an activity studying surface tension in liquids. So this one we are going to do it at home. We are going to do it. We are going to try out. Get let's say a sewing needle. If you don't have a needle, maybe a razor blade, and carefully place it. So they are saying that dish. We are going to study the surface tension in liquids. So what you need a dish, a beaker, cold water. You need cold water, not warm water. You need cold water. There's a reason why you need cold water, and a piece of paper. You need a sewing needle and a metallic paper clip. So caution, needles are sharp, handle them with care. That's the caution. So what is the procedure? They are saying that take a sewing needle and set it down on the top of the water in a bowl. Observe what happens. So if you just get a needle and put it on the surface of the water, that needle is likely to sink to the bottom. Okay. But if you get a piece of paper, a small piece of paper, and that is larger than the needle, and you place it, you carefully place it, you carefully place the needle on that piece of paper, and that paper you place it on water, what will happen? What will happen is that the needle will remain floating on water while the paper will sink to the bottom, Okay. So they are saying I carefully press down the sides of the paper so that they get water logged and the paper sinks. Or you can just wait until the paper sinks on its own and observe and tell us what happens. So I want you to try out this experiment at home. Yeah? Is it very hard? Members, is it hard?
No.
Yes?
No.
People are sounding.
No.
People, are you having breakfast? Are you eating? Yeah? Ruth?
No. Yes.
Okay. So we have this blotting paper. So if you have a paper and then you place a needle on it, we are going to write what will happen. So in your books, I want you to write this, that experiment to demonstrate surface what? Surface tension. All together. An experiment to demonstrate surface tension. Are we together? An experiment to demonstrate surface tension. So you draw this diagram here. This is a paper. Needle. Container. Okay. No, I don't know what's wrong with my camera. I think let me do this like that. So draw that diagram. So we are going to write what is in this experiment. That is the experiment that we shall use to demonstrate surface tension. Okay, that's the experiment we shall use to demonstrate surface tension. So the first thing that you have to do is, so what is your procedure? What are you going to do? You are going to do one by one. So what should be the first thing? Should you first put the blotting paper in the beaker and then you pour water? What should you do first?
First, pour water in the beaker.
Yes, good. So say pour water in a clean what? A clean beaker. Okay, that's the first thing. Then the next thing is
Place a paper.
eh?
Place a paper.
So carefully, isn't it?
Yes.
Carefully place a blotting paper with a needle on the surface, on the water surface, on the water surface. Okay, on the water surface. So what should be, what are you going to observe? Now, all these things, now the observation, because I want you to make this experiment. The observation is going to come when you make this experiment. When you make this experiment. But we can write because we have already seen the video here. When this person placed these two things, these things here, they started the floating, isn't it? They started floating. So even there, when a needle is placed, on the when that needle is placed on the water surface here, what will happen? What we shall observe is that, what shall we observe if the needle is placed with a blotting paper on the surface? What should be our observation?
A blotting paper.
The blotting paper. The blotting paper does what?
Sinks.
The blotting paper. Why does it sink? Absorbs what?
Water.
Absorbs water and sinks. Okay, and sinks. While the pin or the needle does what? Remains
Floats.
what?
Floating.
Remains floating. Due to what?
Floating.
Surface tension.
Due to surface tension. Okay, due to surface tension. Due to surface tension. Okay. So that is how you can demonstrate surface tension. Now they can ask you, explain what happens. What happens when oil or soap solution is added to the water? What happens if you put in soap solution or if you put oil droplets in that water? So what happens? We are going to answer that question. But before we answer that question, I want you to tell me what happens. Do it first try. What happens? Who knows? Pav, what happens?
This is just a rough guess. I think
It's okay.
I think it would. Yes. So I think it would sink. The needle would sink.
The needle will sink. Correct. That is correct. The needle will sink. That is a correct guess. It will sink. Why does it sink? Yes, Sean. Why does it sink?
Because the surface is no longer thin and elastic.
Because the surface is no longer thin and elastic. Why does the soap or the oil, what does it do to the surface of the water? What does it do? What does the oil and the surface of the water, what does it do to the surface tension?
Decreases it.
It decreases the surface tension, or we say it breaks the surface what? the surface tension. So let us see this video and see. So this is where we stopped. Now we can play again and see. So they are there. He has added more and more, and they were floating, 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 and floating, and floating. Okay. Now after he starts to, after he starts to pour soap solution, that is soap. So soap solution, and we are going to see what happens when he adds. You see, they all do what? They all sink. When he pours soap solution, they all sink to the bottom like that. So meaning that the soap solution, breaks the surface tension. Are we together? Are we together?
Yes.
Yes.
Okay, so the soap solution breaks the surface.
Okay, so the soap solution breaks the surface,
And these coins
and these
are
coins
to the
are going
bottom.
to stick to the bottom.
Okay, so let us write that. Let us write that. Okay, so what will be observed? Explain what happens when oil or soap solution is added in water. So the pin, now for that case, it will be the pin. The pin. Okay, we can say not the pin. Okay, the oil breaks the surface tension and the pin sinks to the bottom. Okay, it sinks to the bottom. All right. The other question that can be asked is to explain. Now here, those questions are not there, but here they are asking, add soap solution or oil in the surface of the water and repeat the above procedures. What do you notice? So what you notice is what we have just seen in the video, that the soap solution will break the surface tension and whatever it is on the surface will sink to the bottom. So surface tension, how can surface tension be reduced? Let us write that question. How can surface tension be reduced? How can surface tension be reduced? If you have a question, you can ask, but let us see, how can you reduce surface tension? Who can tell us, how can you reduce surface tension? Who knows the answer? Stop being muted. How do you reduce surface tension? Yes, Ruth?
Yes, Ruth?
By what?
I'm
By
trying.
what?
Yes,
I'm
try.
trying.
Yes.
Adding
Yes,
oil.
right.
Oil to
By?
By?
adding oil to water. Adding oil to water.
Very good. By adding
Very good. By adding
solution in water.
solution in water.
In water, that's one of the
In
ways.
water, that's one of the ways how we can reduce surface
Another
tension.
one.
Another one.
By adding soap.
By adding soap.
Yeah.
Yeah.
When you add soap solutions or
When you
detergent,
add soap solutions or detergent, reduce the surface tension.
So do you know the reason why we used cold water here? Here, where cold water. Do you know why they use cold water? Why they don't use warm water?
Because cold water has more surface tension.
Cold water has more surface tension. So that means that if you increase the temperature, what happens to the surface tension?
It breaks,
It
reduces.
isn't it? That's why sometimes if you use warm water for washing clothes, the dirt comes out faster, isn't it?
Yes.
Yes, because that water has no surface tension, it can easily penetrate in the fibers of the cloth. So if you use warm water has low surface tension. So how can you reduce surface tension? By increasing the temperature. By increasing the what?
Temperature.
Increasing the temperature of the water. So that's why sometimes if you want to wash, you use warm water and then you wash. A washing machine, some of them use warm water and then when they are washing. And then the other thing is that if you want to also wash clothes, you use soap, because soap also reduces surface tension. You cannot use just mere water without soap and you think your clothes will be clean. So because soap reduces surface tension, so the water easily penetrates into the cloth or into the material of the cloth or fibers of the cloth, and the dirt comes out easily. So that's why we use okay, what is the other thing? By adding paraffin or what? Oil in what? In water. This one also reduces surface tension. Are we together?
Yes.
Okay. So those are some of the ways how you can reduce the surface tension. And then how can you increase surface tension is the opposite of this. Okay. Lowering the temperature is one of them. Lowering the temperature. All right. So go and download this book and then you go through these experiments. This one here. You try it out at home and see if really those things can, if a needle can float, or if you get these bottle tops for soda, those ones, bottle tops for soda, the ones which are metallic, and then you bang them and make them flat, and then you try to place them on water, they will float. They will float. So you try that one out and then you see. So next time when we meet, we shall look at capillarity. We shall define what capillarity is. Today, we have not been able to look at capillarity, but next week we shall look at capillarity and we shall look at all this. Capillarity is quite long. I think it needs one lesson and we shall look at capillarity. Okay, we shall look at this, why this one raises more and this one is below. So, I've just given you this assignment. Don't try out. You tell me what you get when we meet next time. If you have any question, you can ask. I'm seeing another person, Hope. Hope.
Yes, yes.
What is the other name? Hope who? Hope.
Bridget.
Hope Lita.
No, Bridget.
Bridget. Hey, Bridget, you have come very late. Almost you have finished the lesson. So, members, I wish you a nice day. May you be blessed and read and revise. Is it okay? In November, you do tests, so make sure that you revise for those tests. Have a good day and bye-bye.